Okay. So now we have done the topic on the fixed wing and rotorcraft. Now, when you come talk about hybrid, what does comes to your mind? What is hybrid? Yes, yes, clear.
Hybrid is a combination of rotorcraft and fixed wing operations.
Correct. So you have seen the pros and cons of both type, right? The fixed wing has what fixed wing can have a higher endurance capacity. It can fly for a longer speed. It can go higher up in the altitude and all those things. Whereas your rotorcraft has an option of hovering in the sky or hovering in the air, and then you can also have vertical takeoff and landing in the rotorcraft. So the whatever the best options are there or best capabilities are there of both type is been combined into two, and then we have created something called as hybrid. Okay, so the best part is that it can hover, it can vertically take off and land. So that best part. So I will create a fixed wing aeroplane which can take off vertically and land vertically, or it can hover at a particular location. If I have this kind of aeroplane, then it will be very easy, right? So just 2 days back only, government has released a new document on certification of called VCA. VCA is nothing but vertically takeoff and landing capable aircraft. Okay, so they have just released the documentation, and you can get certified for VCA because a lot of VCAs are going to be now starting. VCA operations will be starting. That drone taxi, what we are talking about, drone taxi is nothing but a VCA device. Okay, vertical takeoff and landing capable aircrafts. So this, along with the RTR guidelines, along with the vertipod guidelines. So all these guidelines have been released. Now only left out is BVLOS. Okay, so people are only waiting for that BVLS guidelines. Once that is there, then you will see a lot of boom happening around the drone industry also. Lot of new aspects, new chapter will open because of the BVLS guidelines. Okay, so people are just waiting how the rules and regulations would come and how it will be useful and what we can do using BVLS guidelines. Yes, Nishan.
Uh, as we, being students and pilots of Bombay Flying Club, is there any chance for us to, in future to navigate into drone taxis, being pilots for that?
No, no, I didn't get you actually.
So, what if I want to be a drone taxi pilot? Is it possible to?
So,
Yeah.
see, as of now, drone taxi will come into a category in a class of something called large. Okay, so to become a pilot for large, yet the regulations has not been released. Okay, so that will come under the BVLS conditions. Or maybe, see, again, understand one thing. You being a pilot, the pilot, you are not actually going to be inside the drone. You will be flying it remotely. Only the passengers would be there in that drone. You will be sitting in a control center, and you will be flying that drone remotely. Okay, so see, so that safety, because see, when you are in an aeroplane, if something is going wrong, there is a pilot to manage it. Now here the passengers are going and there is nobody to manage or control anything. So that fear factor is also, that human performance is also coming into the picture. So that is what it is delaying. Okay, how people, whether people will have confidence in getting inside those kind of device which is autonomously flying and all that thing. So over the see, initially we had all these incidents or accidents in when aircrafts were getting developed. If you see initial, like there is a one good I had one video also about it. Okay, I'll play it in the afternoon session about how the aircraft accidents were there, how aircraft were getting developed, different types of models were created. So today, whatever that stability, safety factor has come into the aviation, is not that just by like that. People have already faced a lot of failures, lot of issues, lot of accidents, so many things. Over the period of this last 125 years, people have learned about it, and then they have overcome those all barriers or those issues. Okay, so similarly, once government releases, yeah, as of now, only small and medium pilots are there. Large is still not been released because there is no syllabus been set for that. Because they do, even government doesn't know, or DPC doesn't know what and how to set it up. Because even ICAO has not given any guidelines for that. Okay, so it is all, again, people are just randomly testing it. So all this testing, what is happening, that is actually their inputs, and based on that inputs, people will develop the guidelines or the framework and all that. Okay. So hybrid operations and aerodynamics. The principle of aerodynamics, types of hybrid drones and parts, applications of hybrid UAVs. So four forces acting on a drone: lift, weight, thrust, drag. The airflow changes and pressure distribution over the airfoil. So we have seen that how airflow changes by moving the airflow on the top of the wing. It actually moves at a very high speed. So there is a low pressure created, and below the wing there is a slow wind is creating, or airflow is in slow, okay, less velocity. So there will be a high pressure. So this high pressure and low pressure difference is there. That difference will create a lift in the wing or airfoil. Okay, so let's see the airfoil again. Leading edge, we have seen trailing edge. Chord line is a straight line between the leading edge and the trailing edge. Chord is the distance between the leading and the trailing edge measured along the chord line. So this is basically a distance. So what happens, you have a slats. So slats is nothing but extension of this further, and then you have flaps. Flaps is backside. So your chord line is actually getting extended as you extend the flaps and extend the slats front and back. So you are actually the airfoil suction is making bigger. So you have a much better surface area. Okay, so you will have that power pressure difference created more, and you have an effective lift. So during the takeoff, you will normally extend the flaps. Okay, so that your chord line gets more. Okay, so the lower surface of the airfoil between leading edge and trailing edge on the lower surface. Upper surface is the upper surface. The mean camber line. Now, camber line, see, there is two difference: camber line and a chord line. Okay? Camber line defines the shape of the airfoil. So, camber line is the equal distance from upper surface and the lower surface. Okay. So, maximum camber line is at the this part where there is a distance between the upper surface and lower surface. There, lower it will be either at the edges. Okay. So, the maximum thickness of the maximum distance of the lower surface from the upper surface. So, this is basically from a design perspective. Okay, normally you will always have your camber line and a chord line different, but if you have a same camber line and a chord line, then your airfoil is like a what we call uniform structure. Okay, so normally you will see the wing is always in a curved surface. Okay, it's not like a teardrop. Okay, normally if you see, this is like a teardrop structure. Okay, but if you see the wing shape, there will be always like a curve. Okay, the bigger upper part will be on the top, and bigger the trailing edge will be always downwards. Okay, so that it will direct the flow. That is what we call as Sponda effect. Okay, flow the air on the top surface as well as the below surface to come uniformly at the same point. Okay, force acting on hybrid drone. Lift is the force that holds the drone in air. The wing creates most of the lift using airplanes. The weight, which is the force caused by the gravity, the weight of the aeroplane will try to pull down the aeroplane downwards. Thrust is the force that moves an aircraft in a direction of a motion. It is created with a propeller, jet engine, or rocket. Air is pulled in and then pushed out in a opposite direction. One example is household fan. Like household fan, what does it do? It takes the air from the other part and then it direct on your head, right? The same thing here, the aeroplane when it creates, it takes the whatever the front air is there, it will try to push it back. Okay, that's how it will go over the surface of the wing. Drag is the force that acts opposite to the direction of the motion. Since your aeroplane is always moving in a forward direction, so drag will always try to opposite in a opposite direction, because your aeroplane is moving through the air particles or air object air. Okay, so it tends to slow an object. Drag is caused by friction and difference in the air pressure. An example is putting your hand out of a moving car window and filling it pull back. So like if you put just straight away hand out, your hand will go back. If you are having parallel to the ground, you will not feel anything. Okay, it will just feel the air. But as you just stay, your hand will go up, not back. But if you make more, it will go back. Okay? So that's how the drag affects on your aeroplane. Now, what are the parts of the hybrid drones? Part of the hybrid drones are similar to your fixed wing. It will have a wing, okay, the fuselage and the wing attached to it. Okay, the wing will have ailerons. Ailerons will control what motion?
Roll motion.
roll motion. Okay, then you will have a vertical stabilizer and horizontal stabilizer. Vertical stabilizer will have what? Yes,
Pitch.
Rudder.
vertical stabilizer. Vertical
Rudder.
stabilizer. Vertical stabilizer will have rudder, and rudder will control what?
Yaw.
Right.
Yaw.
Yeah.
Yaw means it will change directions. Okay, so these are very small concepts, small points. Okay, very small. You may just take a picture of this, and I have already yesterday sent you on WhatsApp. Okay, you can just take a picture and paste it in your room or whenever. So you every time you see that, you will keep on remembering it. Okay. So wing is with ailerons, horizontal stabilizer is your elevators, vertical stabilizer is your rudder. Horizontal stabilizer is called nothing but elevators, which will control your pitch motion. Okay. Vertical stabilizer will have rudder, which will control yaw motion or direction, and ailerons will control your roll motion. That is your banking on right or banking on left. Okay, so same principles are being used here in hybrid drone, because hybrid drone is like fixed wing. But now since this fixed wing, I do not want to run on a runway. It needs to be take vertically takeoff and landing. So it will have two arm structures. Okay, two arm structures will be there. So on one arm there will be two propellers, and other arm there will be two propellers. So it will be like a quadcopter. Okay, so in hybrid drone, you will in see there are total five motors. Minimum five motors would be there. Okay, so four motors are used only for maneuvering from ground to air. So that is your vertical takeoff and vertical landing. So once you are in the air, it will make transition. That means all these four propellers will stop, and only your one motor, since it is mounted on the back side of the uh, fuselage, it is called as a pusher motor. If the same motor was attached in the front of the fuselage, it would have called as puller motor. Okay, so either position of the motor, it will make the forward directions. Okay, so this motor, this pusher motor will be functioning at that point. So imagine instead of four motors to move, now only one motor is utilizing your battery. Okay, so against four motors, only one motor is utilizing your power. So you will definitely get more endurance capacity, right? These type of drones are useful in like a high terrain areas, like where you cannot have a place to create a runway. Okay, so you need a like Assam, Kerala, or like Ladakh region, where it is very difficult to create runways, where you need your aeroplane to land and take off vertically and then do all our activities. Okay, so as it goes in the air, it does transition from rotorcraft to fixed wing. So once it is in fixed wing, only pusher motor will use. You will get a better endurance capacity, and then you can fly a drone longer. As it completes its mission, it will come back to the position again. It will do the transition from from a fixed wing to a rotorcraft. So again, your pusher motor will stop, and your four motors will start, and then it will start descending at the position. Okay, like this. So this is how the parts of hybrid drones are there. So different configuration of hybrid drone. There are some hybrid drones where have been used to utilize the same motors. So normally, if you see this motor, there are four motors on this drone. Okay, they are in vertical position, so they will take vertical takeoff. As they go up in the air, the orientation of the motor will change. Okay, from vertical position, it will become horizontal position. So in that case, out of four motors, only two motors will rotate. The behind motors will stop rotating. So only front two motors will function, and they will carry the hybrid drone forward direction. So it will be in a horizontal flight. Okay. Once it is completed its mission, again it will do a transition maneuver. So its motors will start spinning. All the four motors will start spinning, and they will change the orientation from horizontal to vertical, and then it will do vertical landing. Even this type of drones are being made for hybrid configuration. So five motors, four motors, and then there are hybrid drones with only two motors also. Okay, so this is five motors. Okay, this is two motors, two or four motors, and this is only with two motors. So this drone is like a wing shape. Okay, this is a wing shape, but it will vertically take off, and as it is in the air, automatically like it will take off like this, and as it is in air, it will do a shift in its orientation like this, and then it will continue moving like a fixed wing. So vertically take off, it will change like this and this. This is one of the beautiful concept. Okay, so people are thinking whether we can design aeroplane like this, but the problem for such kind of small activities, okay, imagine commercial aeroplane we would like to design like this. Is it possible? What would be the challenge? Can you think about it? So one thing you can overcome is that you would not require a runway. So your airports will become shorter, right? But if you design this type of aeroplane for commercial purpose, let's say small, maybe four-seater or six-seater also initially. What would be the challenges? Yes, Priyam.
Um, an average passenger would have a lot of problems dealing with the orientation of the aircraft during launch
Correct.
because,
Because see, it is
yeah,
vertical. So again, like when it is vertical, you may be sitting upside like this, okay,
yes.
parallel. But as you move, you also need to change your position, right? Your orientation also needs to get changed, or else you will have a problem, right? Because आप ऐसे बैठे हो अभी like I am sitting it. If my whole chair changes and if I do not change with the chair, I will be facing downwards, right? I will be facing downwards. So it will be very difficult position for me. It will be very difficult position. So as I move up, okay, and I am sitting here, okay, like this. Imagine this pen is a person. So as it goes up, it will become like this. So that point in time, even my position has to be changed. It has to become perpendicular to the flight path then, right? So this is one of the challenge, how you do overcome this. So they are talking about like we have these recliner chairs and all the things. So there are people are, there are testing is happening on these lines also. They are trying to design aeroplane for small people like four-seater or six-seater kind of thing where it can vertically take off and do it. But then again people are talking like why do we do this? We can simply create a small four-seater straight away, just sit it, put four motors and just vertically fly and fly it. Okay, but here you see the efficiency. Here you are using only two motors, and then rest of your flight is like a fixed wing. So you are efficiently using the power. So again, when it is not only about design, it's not about the flying, but how efficiently you are using your resources, how efficiently you are using power, because power is 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 equivalent to your profits. Okay, so the less power, less fuel consumptions, you will have more profit. You can do more passenger takeover and take off, deliver from one location to another location. So it is always with respect to the power. Okay, so this Wingtra right now is this whatever model you are seeing is Wingtra version one. Now they have released version two. Okay, it is little bit bigger and much better and much stabler. And Wingtra two has even the lidar capacity. So backside of this fuselage they have a camera. Okay, you can put camera, you can put thermal cameras. You can now in the version two you can put lidar also in that. So this is extensively used for surveillance purpose. These drones. So similar type of drones, I am working with one of the company in Rajasthan where they have wanted to develop. So we have actually working on the design part. So we have already designed it. We just thinking about how to make the prototype. I mean, we are just finalizing on the what is the structure, the composites what to be used. Either carbon fiber we want to use or polycarbonate we have to use. So that is what we are not able to finalize because carbon fiber is in times the cost compared to polycarbonate. That is what it is. Types of hybrid drones. Application of hybrid drones is virtual, hybrid VTOLs are used in operations where terrain is difficult. I give example like Assam, Kerala. Okay, it's difficult to land or even Ladakh. It's difficult to land a fixed-wing airplane, but endurance needs more than material. You have both capability or both options available, so hybrid VTOL is the option. It is used in large area. It is used in a transport heavy payload as well as large distance with hilly terrain. Okay, wherever there is a hilly terrain in those areas, I can always use hybrid VTOL. Mostly these hybrid VTOLs also used in search and rescue missions or even in cargo deliveries also. Okay. Any questions so far on applications of hybrid VTOLs?
Sir, I can you come on the previous slide, please?
Yeah.
So, sir, don't you think one challenge over here is the number of passengers it can carry if we put this in
That's
a
what I'm saying.
commercial flight?
Initially, they are not talking about more number of passengers. They are talking about 4 to 6 passengers only.
But that would not be commercially feasible, na, sir? Economically.
Why?
So the amount of power used. So this would be electrically powered.
Yes, yes, electric. This is electric powered only. These are electrically powered motors.
Okay.
Even you have aeroplanes with 4 seater, right? Charter HCS. It's nice 4 seater only. Still, it is viable, right? See, compare to commercial aeroplanes where from Mumbai to, let's say, I want to go to Mumbai to Surat. Okay, in commercial airline, it may cost me 2,000 rupees. But if I go for a charter aeroplane, it may cost me 25,000 rupees. So that difference would be always there. So if allied people who want to fly, like the people who want like Ambani's or Oberais and those people who uses their charter plane services, they will go for that kind of service. It depends upon people, segment to segment it wise. Okay, so with that we covered all the three topics of aerodynamics and operations from fixed wing, rotorcraft, and hybrid. So, for any questions on this, or
Nothing
we
from
are
here.
good? Okay. So after the lunch break, we will start with the weather and meteorology. Let me give you some one or two questions on hybrids, and then we can wind up for first session. So far, are you getting the gist of the theory topic what we have covered, and the questions how it will be asked, and what type of questions would be expecting? So again, I am repeating. I will be repeating every given point in time. Read your summary very well. Okay? The more better you read, you will able to understand and you can answer the question. See, right now you are making. See, and don't haste in giving the answer. You have ample time. 1 minute per question is there in the exam. Okay, 40 minutes and 30 questions. So you have more than 1 minute in fact. Okay, so don't do haste when you are answering it. You have to score 70%. If you are scoring 70%, then only you are eligible for simulator and flying. Okay, or else I have to give you 1 day break, and then you have to again after next day you have to appear for exam. Then only you can go for simulator. Then only you can go for flying. That is what actually the DGCA says. Okay, so you need to be careful what you are trying to learn. Roll control affects which movement? Side to side, left to right, right? So roll right, roll left, what we say. Tail rotor is typically found in tail rotor. Tail rotor. फिक्स विंग में तो नहीं होता है ना टेल रोटर.
But we just saw an example of a hybrid craft that is having a fixed wing with a tail rotor in it.
See, hybrid drone is a different thing. Okay, here we are not talking anywhere. There is no question about hybrid aircraft. Fixed wing aircraft, aircraft doesn't have a tail rotor. This the answer is wrong. Hexacopter and quadcopter are drones. Single rotor drone will have a single rotor will sorry.
Mangesh, can you please repeat your voice is not clear.
Okay, so tail rotor is typically found. Tail rotor is for what purpose? It's to control the centrifugal motion. Okay, so in hexacopter and quadcopter, you do not have that kind of motion over here because these are typically rotorcraft drones. Fixed wing aircraft is flying using using aerodynamics, so you don't require a tail rotor over there. Only single rotor drone. Single rotor drone, if there is no tail rotor to it, what will happen? Your your rotor will move in one direction, whereas the body of below will move in other direction. To counter that, you will always have a tail rotor, like in helicopter. Okay, so single rotor drone will always have a tail rotor. Okay, instead of writing single rotor drone, I could write helicopter also. Okay, uh, just one small point I want to give you.
Sir, single rotor means then helicopter has two rotors, right? One main rotor and one tail rotor. So
Tail rotor,
basic.
yes, yes.
So we technically it's not a single rotor. Just I'm just trying to clarify on that
Yeah,
point.
but that second rotor is not actually helping you for flying. See, the second rotor is the tail rotor is not helping you for flying. It is not used for flying. It is only avoiding the motion of your body. Okay, to stabilize it. It is not
Right.
helping you flying.
Okay.
Flying is only happening with the main rotor. The main
Okay.
rotor, that is a single rotor. The helicopter is always said as a single rotor. Second tail rotor is only to counteract the
Okay.
motion. Okay.
Okay.
Okay. I just wanted to talk about one small point. I was searching for the image, but I didn't see. Hold on, just give me 2 minutes. I want to show you one image. So it is called as FIRs. Okay. So it is called as flight information region. I will show you the. Okay. So I was talking about FIRs. FIRs are nothing but flight information regions. Okay. So these are the regions which are being divided. So our India as a country has been divided into four FIRs. Okay. You can see the image.
Yes.
Okay. So these are the four FIRs of the country. So Mumbai is one of the FIRs, Chennai is one of the FIRs, Kolkata is one of the FIRs, and Delhi. So total four. India is divided into four. There is sub FIR for Kolkata also, which is Guwahati. Okay, the easternmost corner. So this Assam, this seven states, what is there? They are divided into separate FIR, but it is a subset of Kolkata. In all, there are only four. So why these are I'm telling? I just wanted to tell you from perspective how the aeroplane flies. So when I'm flying from Chennai, it is in this FIR region. Okay, so this entire region will be managed by Chennai ATC. The moment I change from Chennai to Mumbai FIR. So Mumbai FIR means Mumbai ATC will take over, and then I had to start communicating with the ATC within the Mumbai FIR. So maybe not immediately ATC of Mumbai will communicate to me. Maybe let's say Kolhapur region or maybe Pune ATC I can communicate, and then I reach near to the Mumbai, I will start communicating with Mumbai ATC. So this is how it is being divided into four regions. Okay, so these are important. Similarly, every country will like they maybe I don't know much about Pakistan or any other, but they will also have their own FIRs divided. Like you can have like since Pakistan is a smaller fire also there. But since India is a very big, large region, they have divided the region into four. Again, Mumbai being the largest because you see the sea part and all the things flying over here, and Chennai is basically covering the Bay of Bengal as well as the other areas in this Chennai and Calcutta. So whereas you see here some FIR like this is under Maldives, this FIR is under Colombo, or this region is managed by the Sri Lankan ATC and all. So this is been managed by Maldives. Okay, this FIR is extended by the Melbourne or Mauritius, pure Seychelles. So all these are different FIRs managed by different countries. From India perspective, we have only four FIRs. Okay, so Delhi, Mumbai, Kolkata, and Chennai. Sub FIR office Kolkata is Guwahati. Okay. So with that, we complete our day one all topics. We will take a break now, and we'll come back at 2:30 and start with the weather and meteorology topic. Okay. So I'll be off this session over here, and once the admin opens at 2:30, I will join back. Okay. So we'll join back at 2:30. Thank you.
Thank you.
Okay. Thank you.
Thank you, sir.